Hello friends, in this video we'll study the limit of a function. Suppose you have a function f of x whose graph is something like this. Okay, this is your x-axis and this is your y is equal to f of x axis, right? And this is the graph of the function. This is your f of x, right? And suppose you have a number in your domain. This is a number a, right? And I want to look at this quantity lim x tending to a f of x. What is this quantity? By definition, this is a quantity to which your function f of x will approach as x approaches a. Okay, what does that mean? It means that as x is approaching a, x is taking values closer to a, where is your f of x heading to, right? For example, you can see there here in the graph that your f of x is heading to this particular value as x is approaching to a. So this particular value is your limit x tending to a of f of x, right? Okay, so this is by the definition of this limit of a function at a point x is equal to a. So the first question that comes in our mind is, why do we need the concept of limit? Why do we need the concept of limit? Okay, okay, for that thing, just look at this function f of x is equal to x square minus 1 upon x minus 1. This is a simple function. You can factorize the numerator. You have x minus 1, x plus 1 upon x minus 1. Okay. And you can further simplify it. You can actually cancel this common factor x minus 1 when x is not equal to 1, because otherwise this factor is 0. So this is actually x plus 1 when x is not equal to 1. And this is 0 by 0 when x is equal to 1. Right. Now look at this quantity 0 by 0. This is an absurd quantity in mathematics. This is an undefined quantity. We don't know what happens when we divide 0 with 0, right? Okay, so it means that for this particular function, x is equal to 1 is kind of black hole. Okay, black hole means we don't know what happens inside black hole. Okay, so it means that when you draw the graph of the function, for example, if you draw the graph of this function y is equal to x square minus 1 upon x minus 1. So you have the straight line y is equal to x plus 1 everywhere. This is the graph of the line y is equal to x plus 1, right? This is x is equal to minus 1 and this is y is equal to 1. Everywhere the graph is the line except at x is equal to 1. At x is equal to 1, the function is taking the value 0 by 0. So you have this hole here, right? And it means that we don't know what happens to this function at x is equal to 1. Okay, that makes us sad because we don't know what happens to our function at x is equal to 1, right? Okay, but then somebody comes and say, okay, don't be sad. If you don't know what happens to your function at x is equal to 1, I can at least tell you what happens to your function in vicinity of x is equal to 1. That makes us little happy. Okay, so from here the concept of limit arises. Okay, from here the concept of limit arises. So it means that if we don't know what happens to function at a particular point and we know at least what happens to the function in the vicinity of that point, that is useful, right? Now let us look at how do we compute limits, right? So I told you what is the definition of limit. Limit is the number to which f of x approaches as x approaches a. Now if you have the graph of function and here is your point a, you can see that you can approach a, x can approach a from two sides, from left hand side and from right hand side. Okay, so x can approach a from left hand side. Okay. In that case, when x approaches a from left hand side, we call that limit as left hand limit. Okay, and we denote it as lim x. We put a negative sign to show that we are talking of left hand limit. It means that our x is approaching from left hand side towards a, and when x approaches to a from right hand side, okay, in that case we call that limit as right hand limit and we denote it as lim x tending to a. We put a positive sign to show that the x is approaching to a from positive side. So this is your left hand limit and this is your right hand limit. If these two quantities are equal, if these two quantities are equal, then we say that limit of f of x at x is equal to a exists, and the common value, the left hand limit and right hand limit, the common value of these two terms is called the limit of the function at that point. Okay. This is how we compute the limit of the function. Now let us look at the example. We had considered this function f of x is equal to x square minus 1 upon x minus 1, and suppose I want to compute what is the limit of this function as x tends to 1. Okay, right. To compute this quantity I have to compute left hand limit and right hand limit, right? So to compute the left hand limit, I have my x should approach to 1 from left hand side, and to compute the right hand limit, my x should approach a 1 from right hand side. So let us compute the left hand limit. When x is approaching to 1 from left hand side, what kind of values it will take? It will take the values like 0.9, 0.99, 0.999 and so on, 0.9999 many times, right? These are the values which x will take when it will approach 1 from left hand side. And what will be the corresponding value of f of x? We know that this is the function, and this function is nothing but x plus 1 when x is not equal to 1. So in these for these values of x is not equal to 1 obviously, so we can take this as x plus 1. So the value of the function value of the function at x is equal to 0.9 will be 0.9 plus 1, so it is 1.9, and the value of the function at 1.99 is 1.99, and the value of the function at this point is 1.99 and so on, 1.9999 many times, right? So you can see that as your x approaches 1, okay, your x is approaching 1, what is your f of x approaching to? You can see that your f of x is approaching to 2. It means that for this particular function, the left hand limit is 2. Okay, now let us look at the right hand limit. If x wants to approach 1 from right hand side, what kind of values it will take? It will take the values like 1.1, 1.01, 1.001 and so on, 1 point many zeros then 1, right? And again when x is not equal to 1, therefore the value of the function is x plus 1. So at this particular value of x, what is the value of f of x? It is 2.1, and here the value is 2.01, here the value is 2.001 and so on, the value is 2 point many zeros and then 1. Okay, again you can see that as x is approaching 1 from right hand side, your f of x is approaching to 2, right? It means that for this particular function, the right hand limit is 2. Okay, now left hand limit and right hand limit, they are same. It means that limit of the function at x is equal to 1 is 2. Okay, but this is not always the case. We do have functions. For example, consider this function f of x is equal to 2 when x is greater than 1 and minus 2 when x is less than is equal to 1. If you draw the graph of this function, it will be something like this. Here you have 1, okay, and the value of the function is 2 when x is greater than 1, and it is minus 2 when x is less than is equal to 1. Now if I want to compute the function limit of the function as x tending to 1, okay, so I have to compute the left hand limit as well as the right hand limit. You can see from, if your x is approaching to 1 from left hand side, the value of the function is minus 2. Okay, in that case the left hand limit will be minus 2 because it is constantly minus 2, and the value of the function from right hand side when x is approaching to 1 from right hand side is 2. So these two quantities are not equal. So for this particular function, limit x tending to 1 f of x does not exist. Okay, thank you.